So कहते हैं ना कि अंत भला तो सब भला.
Yes,
Yes.
yes.
Yes,
So,
yes, yes.
we'll not take much time to introduce you.
Yeah, thank
So,
you.
Professor Dr. Shiv Shankar Kumar, he is currently working as assistant professor at NIT Patna in civil engineering department, and having more than 10 years of experience in teaching and learning and research. So we are happy to have you share. So you are please
Thank you so much, sir.
welcome to our platform. So now platform is yours. You please showcase your expertise in geotechnical engineering. Okay.
Yeah, thank you, sir. So can you please share my slides?
Me or you will share?
I think if you share, that will be nice for. Okay, let me see. Okay, let me see
You
if I
please share.
can.
When I'm sharing, I cannot move anywhere. I have other thing to do.
Okay, share the screen. Actually, I will be presenting from my mobile. So if anyone will be facing any problem, please let me know. Since I
But
have
Shiv,
come,
बैठे कहाँ हो तुम?
sir, I came for a site visit, sir, and I am actually my schedule was given yesterday. So and
No, okay,
I
okay.
think
I was thinking that you are inside a car.
yes sir. And actually the thing is हम लोग site visit पे आए हैं और आज का schedule यहाँ का दिया हुआ था, and the main reason is that I
चलो
am unable to like deny this one also. Already like
चलो
scheduled
चलो
has
कोई
been
नहीं
arranged.
कोई नहीं कोई नहीं कोई नहीं चलो carry on.
So, Shiv Shankar, let me please share because we are presenting through mobile, so I should share.
I think yeah please I request you to please share.
Yes, yes, I understood. So, can you see the screen?
Yeah, I'm able to see.
So just let me make it big screen.
Yeah, thank you, General.
Please
So,
continue.
thank you, Dr. General, and the team for giving me this opportunity to talk in this faculty development program on the application of geotechnical engineering for the sustainable development and resilient structure. And the topic which I have given is ground improvement techniques. So it was also challenging for me because I have done work and like mostly on the dynamics properties of the soil, and it was given to me. So it is challenging, but yes, it was interesting to me also that what new things can be presented at this platform. And what I will be presenting here is the like one of my student like currently he is doing a PhD under me, but the work which I am presenting has completed during his master program at IIT Guwahati, and this is basically related to the soil reinforcement. And here I will be basically not only the presenting and discussing, I will be just giving some of the idea that where the student can do some of the research as well. So that will be one of the things I will be introducing, means I will be putting at the end. But yes, there are many things that can be done uh, uh, in the ground improvement technique. While I was looking this one, I understood that things. So that I try to bring here in for especially for the student who is doing the research. That will be definitely that will be benefited, and that will take out some point from this presentation, and definitely they can go for the research as well. So my topic here is the ground improvement techniques. And when we are going to look into the ground improvement techniques, we always think that what are the need of this ground improvement technique? Because when there will be some kind of need, definitely we can think for some kind of development or modification. Until unless we have a need, we cannot think about any kind of changes or any kind of modifications. So if there will be need, there will be problem, then definitely there will be a solution. So if you are finding the solution, then definitely, sorry, if you are finding the problem, then definitely some solution will come up. So that we are trying to look into. General, please, next slide, please. So as I told you that there is a need of the ground improvement. So what are the need of that ground improvement is there? So when you are looking at the inadequate mechanical properties, then definitely you have to think for the some modification into the ground by several means. Either you are putting some kind of reinforcement or some kind of compaction you are providing, like densification of the soil, or some kind of treatment you are going for. Means there can be many things. If you are finding inadequate mechanical properties of the soil, then definitely if you are looking swelling and shrinkage characteristic, because this is also one of the problem for the swelling type of soil. So if you are looking this kind of problem like swelling and shrinkage, definitely one can think about that how we can arrest that kind of problem. And then definitely, because ultimately you have to make the safe structure. You cannot just design that just for the sake of design. Okay, whatever the soil is there, and you are designing something. You have to look soil first very rigorously, that what kind of soil it is and how it will be behaving. Accordingly, you can think for the design at that particular site, because you all know that the shrinkage soil, as well as the shrinkage soil, mainly if you look at, when you add some amount of water, the volume is going to increase. So when the volume will increase, definitely some amount of pressure will be exerting onto the existing structure or the structure which will be coming up. So definitely that will be creating some issue, and you might have also gone through that uh, differential settlement, some cracking into the buildings, into the walls, that might be possible. So to avoid those kind of situations, definitely we need to look into the ground improvement. And by that way, you can also say that yes, there is a need of that ground improvement. And when you look into the collapsible soil, definitely when you add the water, or even small amount of load, it may collapse significantly. And by that way, since it is collapsing, significant amount of settlement very quickly, very short span of time is going to happen. And by that way, the structure may reflect a different amount of stresses at different places. And by that way, that can create a huge damage to the structure. And when you look into the soft soil, definitely name itself, when you are saying the soft, means whatever the structure you are creating or you are going to design onto the soft soil, that may not sustain because of the bearing capacity or settlement characteristics. So question comes that is there any need for the soil soft soil modification? Yes, because if you are getting only those kind of site, see, there is a one thing that you can avoid this kind of problem by avoiding the site. But it is not always possible to avoid the site, because all the time it is not possible by the government or by the contractor or by the owner that you will be shifting, like they will be shifting the locations, or they will be shifting the places for their for their construction. So whatever the site has been given, that you need to look into. And if some modifications can be done, definitely you need to go for. So whatever the situations here I am showing, everyone can agree that yes, there is a need of the ground improvement. Next, please. So if you look at this particular figure, from here also one can see that yes, there is a need of the ground improvement. Because first soil, if you look at, there is a crack in that one, and one can say what is going to happen with this crack. But if you look into the facility, or if you look into the design, what are the things you are going for? Maybe this kind of crack may not be good for some certain type of the design, but this might be critical for some certain type of design, such as like landfill liners, such as hazardous waste material disposal. So what are the criteria, and how this kind of cracking should be stopped or minimized, that we need to look into. And yes, people are doing the research as well, and you can do also what remedial measures can also possible with this kind of crackings. Now again, if you look at the next figure, there is basically slope failure. So yes, and nowadays, if you look at the slope, stability of the slope, what people are doing, they are using the vertebral grass, they are using kind of geocell. So those kind of guidelines, so those kind of improvement is basically going to impose to save the this structure or this embankment or this slope failure. Same point if you look at the bottom side. Now means if you look the two section, like leg of here person putting over the reinforcement, and the next leg is putting simply onto the soil, so how the soil reflecting you can see. And when you are putting some kind of treatment in terms of the ground improvement, like by putting the reinforcement or some kind of other treatment if you are going for, definitely that can bear the significant amount of load. And by that way, you can say that yes, ground can be improved before putting any kind of structure at that particular site. If you are changing the site, that may be like one of the issue or one of the reason that, okay, you are avoiding the problem, but avoiding the problem is not the solution. We have to face the problem, and by that way we will be getting the solution. And all the time, like as I told, that you will not be in a position to avoid the problem, because site will be given, site will be fixed, and by that way you have to work, and by that way you have to think about the modifications and other kind of changes with that particular material to bring the design or the construction at that particular site. Next, please. So as I told, that the whatever the problem you are getting, once you identify the problem, definitely you can go for the modification. So here, if you look at the geomaterials kind of soil that may be natural or that can be filled soil. So if you look at the soil type and the problem associated, everyone can say that yes, there are problems with each and every soil. Not each soil, but some of the problematic soil I can say, because soft soil, silt soil, organic soil, loose soil, expansive soil, uncontrolled field, dragged material, so solid waste, means whatever the soil type you are looking, definitely it is associating some kind of or reflecting some kind of problem. So when the problem is there, if you once identify the problem, you have to find out the solution as well, because as an as an engineer, you look into the solution as well, and you have to find the solution. If there might be possibility some of the places the where the codal provision doesn't work properly, so you cannot say that codal provision is not working, and then by that way you will be denying the work. No, as an engineer you have to look into, as a practitioner or academician also, we have to look into the solution as well, and by that way the major structure or major outcome will come up onto that particular site. Next, please. So when we are saying that there is a geomaterials, problematic geomaterials, and when you are saying the problematic geomaterials, definitely the problem will always be associated. So question is that what are the strategies you will be following to look or to go for the design over that particular site. So one thing is that avoid the particular site, but avoiding is not the solution. It's running from the problem, means you are not able to face the problem, but the question is uh, whether can be faced or not. But if you are, as I told you, as an engineer will always look into the solution. So avoiding is not a solution we have to look into, as here it is mentioned that design the plant structured accordingly. So whatever the design guidelines or design site has been chosen, accordingly you have to look into for the design. And definitely there can other possibility also, like removal or the replacement of the unsuitable soil, that can also be done. And definitely another important things is that if existing soil can be modified, one attempt can also be taken. And definitely enable enable a cost effective foundation design, means overall whatever the situations you will be going or whatever the modifications you will be going for, you need to look into the cost effective design as well, and by that way you will be going for the design. And another important thing, let's say you are going to some kind of treatment, let's say you are mixing some lime or some kind of other things, means ultimately you somehow you are basically going to add some kind of chemical to the soil, and by that way you can think that some kind of contamination is going to add with that particular soil, and ultimately that contamination can also reach to the water table, and finally it will reach to the us, and ultimately the cycle will be going on. And by that way the question always comes, whether we are going to make a sustainable development, we are going to design or create a sustainable infrastructure that we need to look into. Next, please. So as I told that when the problem will be there, definitely we need to look into the solution. So if you look at the type of soil, that is the organic soil, high plastic clay, low plastic clay, silt, means according to the soil, you have to think about what are the modifications or what are the uh, techniques that can be used to improve the ground. So if you look at the organic soil, definitely there can be that can be modified by using the reinforcement, admixture, as well as the dewatering. So basically, it's all depend on what are the materials and what are their characteristic. Accordingly, we can go for the techniques. It doesn't mean that whatever the soil is there, all the type can be applicable. No, it cannot be. And if you are going to use, that may not be cost effective also. So we, as an engineer, we have to look into the cost effective solution as well. General, please, next. So, what means when you are going for the ground improvement, uh, we all know that some of the techniques are very popular, like compaction, dewatering, admixture, means application of admixture or the grouting, and their enforcement also. So each and every methodology or techniques what you are looking here is not applicable for all type of soil. For the some type of soil, it is very much effective. Like if you look at the compaction, definitely it is very much effective for the sandy type of soil. It is very much effective for silty as well as the gravel type of soil. But if you look at, but among this one, if you look at when you are going to compact, means what you are doing, you are basically densifying the soil structure or soil matrix by removing the air voids. Or when you are going for the dewatering, definitely here also we are making soil particle closer by the expulsion of the pore water which is present within the soil mass. So here you are basically changing the mechanical property by changing by bringing the soil particle closer. And the same if you look at the admixtures. So when you are going to apply the admixture or grouting, you are basically also looking the means here the state of the soil is basically changing. If you look at, means initially, let's say some soft soil is there or some clay type of soil is there. I mean soft soil, let's say soft soil is there, and you are basically adding some kind of admixture in terms of the calcium, lime, you can say, or some other kind of grout. Is basically it is changing the characteristic of the soil as well. So by that way, you are looking the improvement into the soil, existing soil. But when you go for the reinforcement and when you are adding reinforcement to the soil, there might be possibility that the soft clay, it might be possibility that the soft sandy type of soil. But whatever the situation of the soil is there, that you are not basically changing. You may compact it. It isn't. It's not required such kind of compaction if you are putting the reinforcement. But yes, compaction is also required at this place. But even if you look at, if you have seen the previous slide where the figure of the two legs has been given, there you can see when you are putting the reinforcement, means no need to alter the state of the soil. But yes, for the safety point of view, we need go for the further densification or modifications as well. So in this basically presentation, I will be talking about the application of the reinforcement in terms of the geogrid, in terms of the tire chips, and how we can improve the soft ground, that we will be presenting, and that will also be reflecting some research idea for the research student. So next, please. So when you are going for the application of the reinforcement or the other kind of modification technique, like some of the figure here I am showing that the like how the dewatering is going to happen, then how the geosales, and here the bottom four figure you are looking at the application of the lime, and this is also going for the, at the end it's required some compaction. So just putting the lime into the soil, just putting the means reinforcement within the soil will not be that much effective. you have to go for some kind of compaction there also. So by that way, you will be getting the more effective solution of, or more effective compacted ground for the particular design. Next, please. Okay, these are the basically some figures where, so when you are going for the ground improvement, as I told, there can be several way. Like one can go for the ground enforcement, one can go for the ground improvement, and other can go for the treatment. So when you are looking for the reinforcement, definitely that can be kind of stone column, nailing. These all are the process of the reinforcement to improve the ground. And when you are going for the by the compaction or consolidation technique, definitely the middle column, you can see that how the compaction, either by blasting, either by dynamic compaction, or by the compaction grouting, we can improve the ground. And when you go for the treatment, means by using some kind of admixture in terms of the soil cement, in terms of the lime admixture, so those kind of things can be implemented for the ground improvement. So here the what I will be talking is the geosynthetics in terms of the geogrid application as well as the tire chips. So next, please. So when you question always comes why we are going for the application of the this geotextile or geograde. So if you look at the function, definitely it can give us several and multiple function depending on what kind of geogrid or geotextile you are basically using. So here we are using the, we will be talking in terms of the geogrid and along with the sand tire. So here, if you look at the function, that yes, you can see that the geogrid or geotextile has a multiple function, and by that way it can use for many purposes. Next, please. So the methodology, whatever, like compaction means in terms of the application of soil reinforcement, in terms of the admixture adding, in terms of the densification, whatever the techniques you are using, question always comes, what would be the main objective of that particular using that particular ground techniques? Definitely at the end, we will be looking whether the bearing capacity of the soil has been improved or not. Means what would be the permeability conditions with that particular ground, what would be the compressibility conditions of that particular ground. So ultimately we are looking in terms of the strength characteristic, and means you will be at the end, you will be calculating the shear strength parameters like C and phi, as well as the engineering characteristic, you can say also like C, phi, and permeability. And by that way you can also look into whether the ground has been improved or not. Next, please. So here it is very small. So here means the major application means in the previous section, you can see that how the where basically we can apply the, or we can use the geogrades or geotextile. But from the application point of view, this I have kept just because the practical scenario where this is being used. Nowadays, in most of the places, whether you are going for the rail track bed, whether you are going for the sand drain, like in case of the means pipeline design, just to avoid the huge failure, whether you are going for the road pavement, just to look into the long means just to look into the durability, longer run sustainability. So everything's like if you look at the embankment foundation, even the embankment slope also, at many places this geogrid and geotextile geocells are being used to make the safe structure. So these are these basically applications where the engineers can look into the design section for the application of geotextile or geogrid. Next, please. So yes, as I told you that since there is a application of geotextile or geogrid, I will be basically looking the application of geogrid and shredded tire, that how we can implement to improve the soft ground, means soft clay and soft clay bed, you can say that can be very much applicable in case of the pavement design. Because if you look at the pavement stretch of the pavement, if you are getting soft ground, question always comes that can you replace the material, or even if you are replacing the material, whether it will be feasible or cost effective. So instead of replacing, can we think about the modification so that the entire means the load, whatever it will be coming, that can be bear by the soft ground. So that techniques and that thought has been basically implemented at this place, and the improvement was found. I will be discussing here. So when you are looking for the construction of construction like pavement, I told you, or in other kind of construction on the weak or soft clay, that's significantly basically reflecting the less bearing capacity and high settlement characteristic. And that's why it is very much important to look into the the these look into the increase the bearing capacity of the soil so that it can sustain the load. And by that way, geosynthetic materials such as geotextile or geogrid or geocells can be implemented to improve the uh, to improve the settlement criteria as well as the bearing capacity criteria. So when you look into, and also question is that why we have chosen this sand sorry, this tire when the geogrid is capable to, or geogrid is frequently being used for the improving the ground. So if you look at these last line which I have mentioned here, the data which is being basically the tire discarded in India approximately 2,75,000, and this data is I think 3-4 year back data, so this might have also been increased. So you can think that about the management, that how we can think for the management of this kind of tires and where we can manage, because ultimately it will be creating environmental issues also if you are not putting. But yes, when we are saying the environmental issue, it will also come up come up with the soil when we are adding either in terms of the tire chips or the shredded tire, or whatever the fine tires we will be using. Means ultimately there can also be associated some kind of environmental issue. But as an engineer, along with the problem, we always look into the benefits. So when we are looking the benefits in comparison to the problem in higher side, then definitely we can think about the use, and parallelly we can also think that the how to minimize the environmental impact utilizing that particular rubber. So next please. So, as I told that when you are using kind of rubber tire, definitely it can create some kind of environmental issues and uh, means environmental challenges also. But when you are looking for the improvement, means in terms of the durability, in terms of the resistance to the fatigue, flexibility, tensile strength, this kind of materials like tire and geogrid is basically reflecting in significant manner, and by that way we can think about its usability in improving the ground. So that's why for this particular study, the ground this tire chips along with the geogrids, means separate study has also been done along with means only with the tire and along with the tire and geogrid. Next please. Just to reduce the settlement and the improve the bearing capacity. So one can ask that why we have chosen the soft ground and what is the need to improve the soft ground. So if you look into the improvement of the soft ground, so first top two figure, if you look at the how the settlement of that plate or the foundation you can see here is right, significant deformation or settlement we have observed. So if you look at the left side figure, the bearing capacity versus the footing settlement, means in the clay soil, significant amount of means deformation we are getting with a very less amount of bearing pressure. And when you are adding or when you are going for the sand, definitely it is reflecting the high bearing capacity. And by that way, we can think to means when you are putting or when we are going to put the sand tire, question always comes, will only sand will only sorry will on means when you are putting the tire, question always comes, will only tire, or we can mix with some other type of soil. So definitely we are looking some other material along with the tire, that is sand here, which is reflecting very good bearing capacity. And we are also looking that here right hand side figure how the like soft ground without any treatment is giving the huge amount of like he means settlement, right, in case of the soft clay. Next please. So here, this is the this is the schematic diagram what has been studied. So below section, what was the soft ground? That is the undrained this strength was basically defined for that particular soil as 14.5 kPa, and that was based on uh, uh, the the vein shear test. Means basically based on the trial and error, you can say that's amount of water has been added to bring the soil strength within the range of 14.5 kPa. And by that way, if you look at the range of the undrained shear strength of the soil for the soft clay, some range is given, and it comes within the range, and by that way it has been defined that this is the soft clay. And over there, initially we have kept the sand, and you can see here sand tire mixture, and footing is resting over there. And the right side figure you can see without sand, without tire mixture. So how the improvement is going with this particular arrangement, I just show you in the next slide. So here some of the laboratory testing program which has been conducted. So means without tire or with tire, you can see along with the geogrid. So next please. So here, these are the basically criteria or the properties of the soil and geogrid, which has been calculated just before the testing, and finally this has been implemented or used for the testing. So here you can see the relative density. This is the this fall cone means height of fall method has been implemented to achieve the uh, desired density of the 80%, because we all know that if you are going for the higher density of the sand, you will be basically going for the higher bearing capacity of that particular, means it can sustain more load. So by that way, we have not chosen for the loose section, or you can say the means lesser relative density. We have gone for the, and we have opted for the high relative density just to reflect the good bearing capacity. Next, please. Yes, this is the basically the schematic or diagram for the and photographs also, that how the different sections has been prepared before the testing. And you can see, yes, here you can see the vein shear test graph has been reported at this particular place to with the addition of the moisture content. With when we have added the water means continuously we have added, and means while adding the water content, the same time we are checking the this this under shear strength also, vein shear, by that way vein shear strength. And this definitely, this is not the this is basically disturbed. Based on the disturbed sample, you can say this is not the undisturbed sample. So based on the disturbed sample which have been prepared into the tank, and at the particular water content, several times trial and error has been done, and by that way this value has been chosen. Next please. So here I just just show you that here the foundation system. Here you can see the right corner, top right corner, that the homogeneous clay bed, and the sand over the clay. Thereafter sand with the geogrids and with the tire chip. So here the figure, the right hand figure, if you look at the clay which having bearing capacity, you can see bearing pressure which is reflecting nearly 60, nearly 69. So and nearly 69 here based on the experimental means observation. But the same value when we have calculated based on the Meyerhof equation, then nearly 71.96 have found out. So by that way we can say very close to the value which I have, which the student has reported at the for the clay type of soil, means basically soft clay type of soil. So as you increase the sand layer on the top of the clay, you can see without, let's say, the right means figure also I have mentioned here. So top right means right corner, you can say bottom corner. So the sand layer, what here it is mentioning, and thereafter in between sand layer and this clay layer, the geogrid has been kept here. So you can see that with the increase of the sand thickness, like when you increasing the sand thickness, how the bearing pressure of that particular foundation system is basically increasing. So here you can see that with the addition of sand, with the with the fixity of the sand up to a height of 1.5 d, the d is the basically diameter of the footing. So along with the geogrid, you can get nearly 200 kPa of the bearing pressure, nearly 4 times higher you are getting by just inserting the geogrid in between the soft clay and the sand layer. So how the strength is being improved, that you can understand also. Next, please. Here the same, the figure is same here, you can see, but the calculation has been made in terms of the improvement factor. So with respect to the clay, the bottom horizontal line you can see, that is the reference line, and when we are adding the sand layer of height 0.5d, 1d, 1.5d and 2d, plus add means along with that geogrid is also added in between. So all the combination has been tried, and you can see the maximum improvement was reported as or observed with soft clay plus sand of height 1.5d along with the geogrid. And when you are increasing the basically this sand layer, this improvement is not significant. It is basically showing that the reduced value of the improvement factor. This might be due to the stress distribution, how it is going to happen within the soil mass, which is below the foundation. Next, please. So this is basically showing you that the along with the geogrid, the sand tire mixture has also added. So in comparison, yes, I can say that in comparison to only with the geogrid, this entire combination is means not significantly improving, but yes, if you look at the small value also, there is some increment in the strength while adding the tire mixture in the sand. So yes, from here also, from this research, basically I can say that yes, application of sand, application of tire, shredded tire, can be useful for the improvement of the uh, soft clay ground. So from this figure also you can see that how we can improve the bearing capacity of the soil. Basically here the how the force between the this tire chips and the surrounded soil is basically increasing, and by that way basically we are looking that the increment is going to happen. Next, please. So here, this point is basically reflecting the how the settlement or the heave, which is means heave. You can see at figure the left down figure. You can see a figure. So how the heave is going to form just near to the footing, just near to the footing. So question is that whether that can be arrested or that can be minimized. So by the addition of the sand tire, we can also see, yes, that can be reduced significantly. So here, if you look at the top figure, right figure, you can see the graphical figure, right one. So top line, what you are looking the above, that is for the sand and clay and sand. So the heap, what you are looking, that is within the sand mass. So when you are putting the tire into the sand, and also the geogrid in between that layer. Definitely the reduction, huge reduction in the heave you can see from this figure. So by that way we can say yes, implementation of the tire is very much effective for the reduction of the heave, or overall you can say yes, it can be implemented for the ground improvement. Next please. So, that's what I was telling, that means whether with the inclusion of the tire can be improved, it can be improved the soft ground. Yes, as I told that here the same statement I have mentioned, that the inclusion of tire shred along with geogrid improve the bearing capacity and settlement of the foundation, and definitely it can mitigate the surface heave that we have just now we have seen in the previous slide. So this research is basically from based on this one we can say that yes, it can mean sand tire shred you can see can be implemented as a one of the ground improvement material. And here I have just for the research point of view, here I have added the tire chips of size 1 centimeter, but researcher can use the fine grain tire shred for the for the sake of understanding whether the ground is being improved with that particular type of means threaded tire or not. So by that way, basically one thing is that you will be getting the improved ground, and another thing is that you will be looking the sustainable environment also. And yes, some of the like environmental impact will also be there while using the tire with the sand, but that need to be relooked by the environmental impact assessment, by the testing with the environmental study, by the environmental study. So here, so like when you are going for the means just summarizing I am this one. So when you are going for the ground improvement techniques, definitely or ultimately you can think about the densification, solidification, replacement, or lowering the groundwater table, or dissipating the excess pore water pressure. So the question is that what are the different methodologies? Definitely several methodologies are already in the exist, but yes, some of the techniques utilizing that itself can be go for the research, can be done, can be implemented into the research by the research scholar or MTech students. So next please. So here, as I told, that the further the explore about means student can explore about the application of sand tire, means application of tire thread, or you can say the threaded tire, maybe different sizes with geocell reinforcement over the soft subgrade for the better performance of the stability of foundation resting onto the soft ground. So here some of the figure I have given here. So here you can see geocells is being used, and yes, that geocell is basically packed by the filled by the material, some ground material or geomaterials. So the question is that, like, if you are using threaded tire along with that material, what extent the means what extent of the improvement can be made with that kind of application? So this is basically a research point of view. Student can go for the research utilizing this point basically. So next please. Yeah, thank you. With this, basically, I would say thank you, Janarul, and thank you one and all present here for listen means peacefully. So, any question, any doubt, if you have, please.
First, let me thank you, Shiv Shankar. I'm so happy to have you because even though I have put you in tough situation, you had a site visit today. Still, you somehow managed to appear in front of us for your delivery. So that is the beauty in your cooperation with us. And we all faculty are grateful and thankful to you, Shiv Shankar. We love you. Okay.
Thank you so
So,
much, General, for giving me this opportunity. So, it's after so long time we are interacting with each other also. So, thank you so much. Thank you one and all, and thank you one and all present here. I think Arindam sir is here, sir.
Yes,
Maybe
yes.
sir has
So I
left.
was listening.
Okay, sir. Okay, sir. Okay, sir. Thank you, sir. Thank you for listening me, sir.
It's always interesting to listen.
I have a little question.
Hello.
Yes, yes, please. Yes,
Hello.
yes, please.
Hello, sir.
Yes, please.
Sir, can you explain me about test setup? So how we have done
See,
making a tank?
actually, this I have
Yes.
not done.
Yes.
One of my PhD student right now he's doing under me, but he has done his master under my supervisor, like Dr. MTech supervisor, Dr. A. Murli Krishna, and now like recently we have published that work along with Murli Krishna sir and me and like student. So that work I am presenting. So the thing is that there is a tank. If you visit IIT Guwahati laboratory, if you're getting some time, then you can visit there, or in other laboratory where this kind of facility. Basically, 1 meter by 1 meter tank is there. So in that tank, I think General, can you bring the slide number 4 or 5? Maybe some
Yeah.
figure over there. So
Yeah.
firstly,
This.
yeah, no, back figure number 5, maybe initial section somewhere it will be.
Back, sir. Still back.
No.
Yeah, here, next please.
Still next. No, sir. Still back.
No,
Sir, setup is there, sir.
setup figure is there. Next.
Still.
Yes, this one. Yes.
Back.
So here you can see the right side figure. The first figure, soft clay bed. Okay. So firstly, what have been done? Like the clay was identified, means soft clay was identified, which will be means not soft clay was identified. Basically, the soil was brought from some locations, and that have been basically means in that one some amount of water has been poured initially. Not means some amount of soil has been taken, small amount of, and in that some amount of water has been poured to look that whether that will be reflecting the loose soil or soft soil, sorry, not loose, soft soil. So that was identified based on the undrained bearing capacity. So undrained shear strength. And when you all know that when you are adding the water into clay soil, the strength of that particular soil will be reducing. And if you look at the range of the soft clay, range of the undrained strength of the soft clay, it is coming under the range of 0 to 0. Definitely 0 will not be, but means maybe 2 to 25 within that range. So you can put 6 kPa, you can put 13 kPa, you can put 20 kPa, whatever the value, it is reflecting the soft soil. So in this study, the student was basically choosing the 14.5 value and indicated that as a soft soil. So what happened? That means initially they have kept the mold into this tank in layer wise and at different locations, means they have collected the sample also just to check back that whether the kept the soil into the tank is similar under strength or not. So the trial has also been done in the tank and found that the placing, the how whatever the placing technique they have adopted just to into the tank, that is also reflecting the same value of the shear strength, and by that way they continued the test.
Okay, sir. Thank you, sir.
Thank you, Shankar.
And recently, this paper has already been published in Indian Geotechnical Journal and International Journal of Geosynthetics and Ground Engineering. So students are requested to go through there if you are like getting more idea, if you want to get more idea in that one. So detailed explanation is given in that one.
Yes, sir. Yes.
So I have a small query. Shiv, if you allow me.
Yes, please.
Actually, I know I have seen from your research paper and your work what you did during your PhD days, and also what you teach in your BTech, MTech courses. I
Yes,
can
yes.
see you are a triaxial testing expert, right?
Yes.
Am I wrong?
And I cannot say that I am the expert, but yes, I used and some of the things I know, and by that way, within that limited situations, you can say, yes, I know something.
And you have idea of cyclic triaxial testing.
Yes, I have a good idea in that cyclic triaxial test. I
Thank
definitely say.
you for confirming. So can I ask you how you can apply your that expertise of triaxial testing facility to
Uh-huh.
improve the ground truth technique? How? What is the way? How
See, yes. See, the cyclic triaxial test generally we do to look into the dynamic characteristic of the soil or reinforced soil also. You can see means whatever the soil is there with you, dynamic characteristic means under the dynamic loading, that dynamic loading may be transient type, that may be sinusoidal type, right? But generally if you look into the realistic scenario, that is basically vibration or that is transient type of motion. So basically how the variation of the strain and the stress is going to happen, along with that, if the soil is reflecting liquefaction, then up to what is extent and how that will be showing the liquefaction into that particular soil. And since you are saying that how can be implemented and for the improvement, right, ground improvement. So the question is, suppose if some of the soil you are saying that it is susceptible to the liquefaction, you know, one of the major challenges in the design when this kind of soil is basically observed. So question always comes that what are the techniques you will be implementing to reduce that phenomena, right?
Yeah.
So definitely researcher have also used, as I told you, that application of this tire can be done in the various way, not only for this static loading. If you implement for the student point of view, I'm saying that for the research point of view, if any student is interested to do some research with the study about the liquefaction potential of some soil with the application of sand tire, they can feel that how the liquefaction potential can be reduced, or in other term you can say how the ground can be improved.
Yeah. So that's the beauty. I understood. So are there anyone from the participant side having some doubts? So you please unmute and ask. So
I
Shankar, you are
think
still inside.
I think no one is.
So let us say goodbye. Let us say you have a nice evening. It's 6:15.
Yeah,
So
it's 6:15, and
Shankar,
still I have to look into the site. Actually, I came with my student and I send him to the particular location to collect some soil. I will be visiting there. So thank you, General,
Okay,
and thank
please
you
take
all
care
the
of the meeting.
participants.
Yes. So thank you. Have a nice evening and bye bye.
Thank you. Bye bye. May I leave this?